Hi, I'm Effie, and today I want to take you through an introduction of working with AOSP. What does it mean? What tools do you need? How do you even approach AOSP? And I'm going to give you the main takeaways right out the front. And I've summed them up into a few bullet points. The first one is that while AOSP may seem scary, with a little bit of extra knowledge, and I'm really talking a little bit, we can really bring our own existing tools and knowledge and develop very similar or even identical to how we develop for Android apps. And the few extra tools that are there to help us manage a large code base or build a larger code base. And once we get to know them, they're just a bunch of extra tools, nothing magical about them. It's all there. The meaning of AOSP open source means that all the code is out there. There's no more black boxes. Everything, we can figure it out. We can read the code. And it also means that the code search, AOSP code search, is really the most useful tool that we can have in our belt for this journey. So I want to start a little bit about talking about how AOSP is structured. And I'm not going to go super deep into each one of these levels. What I want you to maybe conceptualize is that AOSP, as a general, is made out of two big blocks and divided into the hardware manufacturer, the bottom block, and the AOSP contributors and Google contributors, which is the top part. The top part is what we call AOSP. This is the open source part. This is the part we can read. This is the part we have access to. The bottom part, which is all the drivers, all the things that are hardware specific, are also being developed by the manufacturers. Those are usually not public, with a few exceptions. And even when they are public, they're often public as binaries, so they're not public as code. So the bottom part is really sort of out of reach unless you work with or for one of these companies. So if you work for Samsung, you'll have access to these drivers and to these binaries, or with Samsung as a partner. But if you don't, then when we're talking about the changes that we as developers can make to AOSP, we're really talking about the top layer. Now, when we build AOSP, we will build a few different images that we can later burn on a device or flash on a device. And they are conveniently separated by sort of domains, where the system image is usually the Android framework itself. The boot image is the kernel, the RAM disk, the Linux kernel, etc. The vendor image is all this vendor-specific code, all the drivers that I mentioned, all the things that are proprietary code. And the OEM image is where all the carrier-related configurations and customizations would live. It's a really sort of bird's eye view, and there's a bunch of other images, but just to name the most important ones. So what can we build AOSP for? The first and easiest thing to do is to build for an emulator. We don't need any specific drivers or stuff that is related to hardware because we don't have any hardware. So just building for an emulator is something we can do out of the box with AOSP, no questions asked. And when we build our own custom AOSP image, we can later create our own specific emulator AVDs from and use them as the same as we use any other image that we can download from Google. And we will get this amazing, super new emulator image. Looks very 2010 sort. It is, of course, does not have any of the Google-related Play services stuff in apps. Those are, again, proprietary and they're separated from AOSP. So we're back to sort of the very basic bundle of apps and the very basic appearance of AOSP without any of those Google-specific things. The other devices we can build for quite easily are all the Google hardware manufactured devices, such as the Pixel. And the reason for this is because Google releases those drivers as binaries, and we can download them, take these binaries. They often even come as the image itself, so it's not like we can read again. The code is hidden from us. It's not like we can read this code or change it in any way. It comes as blobs. We copy them into our build folder, into our AOSP build folder. And when we put it there in the right folder, we can build all the Google manufactured devices, for all the Google manufactured devices. The other route that is possible to take, and they have a few more devices options, are using Lineage. Lineage is an Android inspired. They fork Android, they change it, they make some changes to it, and they offer a wider range of devices that they support. This option is also really good, by the way, for very old devices that Google doesn't officially support anymore and doesn't actually release new releases to. There's often going to be a release for it in Lineage. So if we go to the Lineage official page, we can find a bunch more manufacturers and binaries that they obtain and support. And if you're lucky, then your device will be on that list. All right, so we have something we want to do, we want to change, we want to make some customizations to AOSP. What changes can we actually make, again, as software engineers? And this is, again, similar to the image I showed before, only slightly different. But again, what we can change and what we have access to are these top two layers, the Android OS frameworks and the OEM apps, the apps that come with AOSP. We can add our own apps to that if we want. So some examples of changes that we can make, we can change the system apps, or we can add our own system apps. We can completely switch the launcher and change it into a completely different launcher. We can access and use SDK APIs and frameworks, even those that have restricted access from us as regular Android developers, because these system apps are bundled into AOSP. So because they're bundled into AOSP, they have access and permissions to access the frameworks themselves. We can change the status bar, we can change the navigation bar, the way they look, the way they behave. And we can also change how the framework itself reacts. So I don't know if we really wanted to change how the animation between apps work. This is something that we could do. Now, at the end of the day, AOSP is just code. It is a lot of code, but it is just code and it is human readable. Java, some C and C++, the higher up you go, the more Java and even Kotlin you will see. It is, like I mentioned, a pretty big code base. It is an entire operating system. So yeah, it's over 1,000 Git repositories. It's over 100 gigabytes of source code. So it's just a lot of code. So what tools do I need as a sort of indie AOSP developer to get started and develop for AOSP? So the first thing is a Linux machine. AOSP is not currently supported to build on any other platform. And I put the image of the Windows WSL here because it does work. You can build and you can run AOSP on a Linux machine, with the exception that you cannot run the emulator from WSL. WSL is in on itself a virtualized machine, so you cannot run virtualization on top of virtualization. I did try to run the emulator on the Windows side and debug with ADB from the Linux side to the Windows side on the same computer. No good, didn't go. It was fun for a while, but it didn't work. So if you are in the business of getting a Linux machine, a very good option to do is, you can build your own server. A very good alternative to it is just get a dedicated server. And the reason for that is that this machine needs to be pretty powerful. It is a lot of code to build. And for example, going back to WSL on Windows, which was like my very sad laptop, it took about 7 hours to build AOSP. That's kind of a lot. So you really want a strong machine. Now, with the space requirements, the CPU requirements, the memory requirements, if you try to build on a cloud, you will end up kind of paying a lot of money for that. So the cheaper option is really just a dedicated server or building your own server, which I linked to a post here from Al about a little bit of what you're looking for in terms of resources and what you need. And you can look into that and figure out what works best for you. And with the machine that I just showed you earlier, the build was much faster. Because I used a server, that I did not use a local server that sits on my desk. I used a remote server that I got from Hetzner. I used these 2 apps. I added these 2 apps on top of it, which I can wholeheartedly recommend to my toolbox. One of them is a remote desktop, no machine. It creates a virtual desktop on a server which has no attached display. And it allows me to connect to it remotely and just pretend it's here, basically. And the other tool that I really can recommend a lot is called Tailscale. Tailscale is a Mesh VPN virtual private network. So it can take, you install the app, there's no configuration required, and it can take any machine from anywhere in the world and pretend they're all sitting on your own local network. And it doesn't matter if they're separated by firewalls or subnets. You just can connect to them as if they're just right here next to you on the very same network. It makes things super easy when it comes to setuping and security and a bunch of how do I SSH into something, makes it super easy, very recommended. And the 4th tool that I can recommend is GitLab. So if you're going into changing AOSP, and you're not just adding apps, for example, adding apps is, okay, you can just add an app here and there. But if you're really going into changing the framework itself, at some point you're going to want to track those changes and you're going to want to put them in a source control. Now, it is not really possible to do this on GitHub because these repositories are, one, there's a lot of them, there's more than 1,000, and 2, they're just too big. Like GitHub really doesn't enjoy this or doesn't like this at all. So putting GitLab on your own Docker, and again, having some space for it and some of self-contained GitLab instance is what we did in this case. And GitLab is really good for this job for 2 reasons. One of them is that it has an automatic import of all these thousands of repositories. So instead of going one by one and cloning them into your own local whatever instance of source control you have, it can do all of the thousands alone automatically. And the other thing that's really useful is that it has these subcategories that you can see at the very bottom, where it has groups, that you can group a few repositories together, which is also something that happens on AOSP. And they built this feature, especially the importing of more than 1,000 repositories. They built this in mind when they were thinking about AOSP. So they were like, literally, oh, we have a use case, AOSP. Here we go. So let's cover a little bit more about AOSP tooling itself. So what tools does AOSP come with? The first one that you'll see a lot is repo. Now, AOSP is, like I said, more than 1,000 Git repositories. If you navigate into any one of these folders and you try and do Git commands, you can totally do it. But if you want to do Git commands on more than 1,000 repositories, then again, you kind of need an aggregator. And this is what repo is. It's a Python program, and you can run a command that will run on the entire tree. At the base of repo is an XML file that just has a list of all the projects, where do they go, which folders do they go, where do they get cloned from, and the first step of using repo is to download this XML, and then the second step would be to perform operations on all these projects. The second tool that AOSP comes with is this env setup script, which has a bunch of commands that we're going to talk about in a minute. It's usually just the first thing you do after getting the source code, and it sets up your environment. One of the commands that it has is launch. And you can build AOSP for a lot of things, and you can even set your own targets to build AOSP. You can say, okay, I want to set AOSP to build Effie stuff. And you can even build a few of them in parallel. You can have a build for a TV, and a build for a phone, and a build for the emulator. And these are basically a list that kind of would remind us of things like flavor and variants of our Gradle. And it's like, okay, which one of them, usually you'll hit the word launch, it will tell you what of all these options that I know about you want to build. You'll tell it the number, or yeah, you can tell it, I want this one. And then the next thing it will do is it will set up the build target, and will set up all these variables and all these parameters about what build are we building. So in this case, for example, we're building for architecture 8664. We're building a custom variant of that we call Lottie emulator. We're the ones that named it in that case. We're building for Linux. This will also work on Windows, et cetera, et cetera. Now, let's talk about build system. So what we usually use is we use Gradle, and we have files called gradle.build, and our Gradle goes over them, knows which other Gradle files to dig up, runs through all of them, and makes our project. So AOSP does not use Gradle. They use these two systems called Android Make, which the files, instead of, again, being called gradle.build, are called in this instance android.mk, and Sunk, which the files will be named android.bp. Now, there is also a third, but these are the ones that are used currently in the code base. They have their own syntax. It's not the same as Gradle, but this is very easy to find. There's good documentation about it. If you Google it up or look into the documentation from Google, there's plenty of explanations of how to write Android MKs and how to write VPs. So it's very approachable in that sense. And it's a little bit this similar process where the first step that happens when building AOSP is going over the entire tree of files, the entire tree of projects, bringing up all these Android MK and Android BP files, making a giant list of rules out of them. We're going to build all these things, and then starting to build them. So kind of recap, which also brings us to, okay, this is how we start working. This would be the first thing we try, the first thing we kind of do. We want to make our first build. How do we start? And then we will start by doing repo init with the URL of the XML file that has all the repositories that we want to pull from. Repo sync will actually git clone all these repositories. We will start the environment setup variables and start these commands, these commands will be recognized. We'll pick our launch and our target menu, and then we'll hit the command make, which will build Android for us. Another command that I want to touch base on that is very useful for developers is the AIDE-gen command. It configures Android Studio or IntelliJ project files with the relevant module dependencies resolved. So because we don't have those files, those, I don't know, IntelliJ files or those Android Studio files in our folders, and we want these connections between files, we don't want to open a file and not know maybe how to navigate to who is using it, or navigate to the source of this, or go to definition. We like these options when we are using an IDE. And this command gives us this definition, this file. So it will launch the IDE with a specific subproject or with a specific build target, and it will help us reach a state that when we open IntelliJ, we will see something familiar. We will see something that we like, and we can see what's the source of a certain thing, or how to go to definition, or who uses it, and everything we're kind of used to when navigating a large code base that is more than just a list of files. All right, so let's talk about how do we develop. And if we said a few times that we can develop for the framework and we can develop system apps, we're going to talk about these two parts separately. I'm going to actually start with the framework. If we want to make changes to the framework, this is the best we can do. This is where we are. This is where we'll be. This is where we'll spend our time. This is where a Googler will spend their time if they're working on these classes. But if we want to build an app for AOSP that is a system app, there's no reason we can't be here. We want to be where we are familiar with. We want to write apps the way we write apps. We want to use Gradle. We want to be able to deploy locally from our Windows or Mac straight into an emulator or even a phone with the app already embedded in it. And we just want to have our normal flow. And the good news is that we can. I've laid down some recipes about how you can get from having something like this to having something like this locally on your computer and without even having to build AOSP all over again. These recipes and these slides in general are available, so you don't have to bother remembering, memorizing, or trying to quickly think about how to do this. It's all out there. And if we want to work the way we normally work, we want to take our app, we can do it in these 5 steps. We can take our Gradle app and put it in the AOSP build. So build AOSP with our app embedded in it as a system app. We can create an emulator image from this build. Then if we both locally in our Gradle app and on AOSP sign the app with the same key, then they will be recognized as being the same app. And from there, if we deploy locally, if we take both these emulator images and we continue writing our app locally and deploy it, we can just use our own Android Studio. We can use everything we know, enjoy, and like. And there are a lot of advantages to this. One of them is that, like I said, you don't have to build AOSP every time for that. You're just changing one APK, and you just deploy it over and over again. And eventually, you can take this APK, I don't know, once a day, once a week, once every release, and put it back into your AOSP build. The other thing that's nice is that we use all the tools we already know. We can use Gradle. We can use any external libraries that we want. We can use Compose. If we're building in AOSP, we are restricted to whatever AOSP has and provides for us. But if we're building on our own, we can use any other third-party library that we want. So let's go over these steps a little one by one. So step 1, we said we want to embed our normal Gradle build app into the AOSP build. We take it, we copy it, we throw it into the AOSP build, and we need to add this file, the Android blueprint file. Why? Because now we need to tell AOSP what to do with this APK, how to build it, what to do with it. So, how did we get there? We need an Android BP for our APK. Now we also need maybe to track this. We need this app to come from somewhere, maybe our own repositories. And then when we build AOSP, we have both the APK that came from somewhere else, that came from even from GitHub in that instance. And we have this BP that tells us what to do with this APK, how to refer to it, how to sign it, how to use it. And we build AOSP. We will build AOSP with our own APK already embedded in it from the start. So this is an example of the Android BP that we used for this particular APK. What's interesting maybe here is that, for instance, the certificate here, we're telling it sign this APK with the same signature as the platform. We're also telling it we're privileged and cool, and we can use APIs that maybe not be accessible to apps that don't have these permissions. And the second thing would be to add this to the list of repositories that we can fetch from somewhere remote. And this we can do, we can just add it even as a different file to repo, because repo is not only aggregating repositories, it's also aggregating manifest files. So we created a manifest file, we added our own repository to it, we added whatever name we wanted for it, where it is, how to access it. And now when we put this in the right folders, when we put this into the repo folder, next time we do repo sync, we'll get our own repo also into the AOSP codebase, and we will get, hold back here, we will get here. This folder will be created, these files will be added to it. And then when we run the make command, now AOSP will, oh, there's a new file here that I can look into, and it tells me to take this APK and embed it into AOSP with this certificate and these permissions. Cool, let me do that. And next time we have an emulator image, we have an emulator image with our own app embedded in it. So step 1, good to go. Step 2, create the emulator image itself. So this is some manual work. We need, if we want to take this emulator image file and move it from Linux machine, wherever we built it, we want to move it into our own computer, we want to move it into our Mac, we want to move it into our Windows machine, we want to work on it locally. So we need a zip file with all the images that we just created. We need to copy this file from the server into our own SDK location on our Windows or Mac development box. The third step, which is the add properties XML, is something that Android Studio uses to display the list of emulator images you can use. Without it, the Android Studio will just not know that you can create an emulator image out of this. And the fourth step will be to create an AVD with your image from Android Studio the same way you do with any other image that you would otherwise download from Google. So step 1, we want to create the zip file that just has all these emulator images. So we make the AOSP project on the server, and then we run this command called make SDK and SDK repo. Now, this is officially the way to do it, but for some reason this has been broken. I don't know why. This command works instead and does the same thing, make emulator image zip, and returns this wonderfully named zip file with all the images, etc., ready to be copied and pasted into our own computer. So that's going to be our next step. Take the zip file, we extract it into our own computer, into wherever it is that we're holding our SDK folder, in this case, it's 33 because that was the latest, but by the time this talk passes a month, who knows? And it will create this folder that we see under called x8664, and in it will be all the files that you need to create an AVD image out of. So now we got 1 and 2. We're ready for this thing called the properties XML. Because now if we open Android Studio, it will just not give us this option of creating an AVD, and we'll be like, but why? The reason is it needs this property XML. You can literally just take it, copy it from another folder, copy it from Android 32 images into Android 33. Change a bunch of stuff, which is what I did here. I just, okay, API level is now 33, I guess, and the display name is Lottie system image, whatever. And save it, make sure it's in the same folder, and open Android Studio. Let's try and make an AVD out of it, and now we will actually see it on the list of available options to create emulators from. Phew, all right. So now we have AOSP built with our app, and we have an emulator image for this AOSP build, for this very specific AOSP build. The third thing we need to do, so let's go back here. Now we can run this emulator image, and we will see our app embedded. We will see our app into this AOSP build. We can see it, we can open it. And now we're working locally, again, on our Windows or Mac. We can hit play, we can make changes to it. We make changes to the code, yada, yada. Now we want to deploy it again. The first thing it will tell you is that, hey, the signatures, the signing keys don't match. Why? Because if we go back a ton of ways, we actually told it to override the signature with the certificate with the platform certificate, which is not the same as our debug certificate or release or whatever it is. These are different certificates. We need to take the AOSP certificate and put it in our Gradle file. So going back all the way. Now, they are the AOSP signing keys, the AOSP key store is different. We need to import the format that they're in into JKS key store, which is what we use on Gradle, which is what we use on Android. There's a boring list of commands of how to do it. This is the link. Follow this link. There's nothing very clever to do there, just to do it. And then when we add it to our own file, to our own JKS file, we can just, again, do whatever we do with other signing configs and just add it. Okay, I added it as this alias, this password, the file from here, etc. And now when we deploy locally whatever changes we made, we're like, okay, cool, you still have the same signature. Go. All right. 1, 2, and 3 done. And now we can deploy locally and work. We're here. We're literally here. We're going to make some changes, work, hit run, hit build. It will override whatever copy was initially embedded into this AOSP build into this. When we're ready, when we have made enough changes, we can commit this to our whatever source control we use. We can build this APK, go back, embed it into AOSP, and then we can build a new image with the changes. But we don't need to do this on a day-to-day basis, just as we work for every time we make every little change. All right, we're close to profit. Are we, though? Because the next thing we'll try to do is use restricted APIs. Because now, if we signed our app as a special privileged app and we told that we're cool, we should be able to do all these things that are usually not available to normal app developers. And here, in this case, I'm seeing that not only I cannot use this secret user handle all, I can't even, it doesn't exist. So why is that? This is because this is a system API. And when the public SDKs are being built, the public SDKs are the SDKs that we build against on Android Studio. These are stripped out of all these secret APIs. So this is maybe a thing to clarify. The public SDK is just the SDK that we're building against. It's not a part of our app. Here, it's building against SDK 32, or even the public SDK 33. In that SDK, all these secret APIs are stripped. They're just not existing. So that's why our local build wouldn't pass. But if we took this all the way to the AOSP side, and we would try to build our app with MK, et cetera, it would build, because we are supposed to have access to all these system APIs and hide APIs, because we have the right certificate for it. So it's not a question about whether we have to change the SDK. We don't have to change the SDK for this to work on the AOSP side. But we have to trick our local build, our Gradle build, to think that these APIs, for this matter, even exist, because the public SDK doesn't even have them. It doesn't recognize the Android Studio doesn't recognize them, because for Android Studio's concern, it doesn't exist. And here, this is what we just summarized. The SDK we compile against doesn't even know we can access these APIs. And this is where we come into this tricky trick. We want to build a custom SDK, not because we want to ship this custom SDK. We want to build it just to be able to use it locally on our machine, because we want to be able to use all these APIs, and we want our APK to compile. Once we take our APK and compile it and put it into the AOSP build, it will work. So this is more of a trick or more of a hack just to get past this problem. And when we're doing this hack, we're just using the knowledge that the annotation processor is sort of a later pass on the classes. If when building AOSP, the first step will be to build the classes fully with everything included in them. And the second pass is only when building a public SDK or building an SDK that is later released to developers, is stripping all these methods or all these properties that have these annotations from them and taking them out of these files completely. So if we go into our own AOSP build and we look into all the intermediate classes that were built, but were built before this annotation processing happened, we can just take those. So we take those with some zip magic. We create an SDK that is our sort of cheating SDK. We move that to our dev computer and compile against that locally. And then we get our magic. So we make the SDK the same way we did before, and we take those files with all these classes and all these properties and all these methods before the annotation processor stripped them away. With some zip magic, we replace them with those the final ones with the original ones. We take this SDK that we created and move it over to our dev computer and just tell Gradle to build locally against it. Instead of building against, I don't know, 32, 33, whatever official downloaded from Google, we're now building against our cheating one. And now it has all these properties. It can recognize that we are able to access them, that they exist, basically. All right, very last thing. Very last thing, and is the most useful thing to have in your toolbox when you build for AOSP, is searching the AOSP codebase. And cs.android.com, go there, Google anything, any name file, any particular thing you want to know. Oh, you want to know how Google sets airplane mode in their setting app? You can find it here. And when you find it here, you get a similar, or at least close to an IDE experience. You can, from here, also find usages, go to definition, see the history of commits of this particular file, sometimes read the whatever documentation there was, or more often wasn't. But the point of this is that this is all code, this is all available, this is all open source, and yeah, so use that. And that's it. Feel free to come up to me if you have any questions or comments, and thank you so much for listening.